Welcome back to Transcended Institute. In today's discussion, we are going to talk about different questions underlog, and these questions came in 2023, one of the quiz, and these questions are under logarithmic functions and exponential. Okay, so let's start. So, how can you find the exact value of these two questions? So, the first question that I have is log base of 1 over 3 of 81, and the second one is log base 2 of 1 over 64. Okay, so whenever you are trying to simplify logs, what I'm going to advise you is in this case I'm trying to simplify this without using a calculator. Okay, so now I'm going to equate this log base 1 over 3 of 81 to be equal to x. So in this case, I'm trying to find the value of x. When I find the value of x, then that is going to be my what? That is going to be my answer. Okay? The reason why I'm going to equate to x because it is in base 1 over 3. I can't make 81 to be the same as the base. It's going to be difficult. But in a case where you can make this 81 to be the same as the base, then that is okay. Okay? That is okay. So what I'm going to do now is I'm going to convert this from log to exponential. So how do we convert from log to exponential? So the base raised to the power what is outside is equal to 81. What do I mean? So 1 over 3 in the bracket raised to the power x is equal to 81. Now at this point, I can now solve this. So 1 over 3 is basically the same as 3 raised to the power negative 1. So outside there is x is equal to 81. So x can come now inside with negative 1, and that becomes 3 raised to the power negative x is equal to 81. Now at this point, I can make the base to be the same. Okay? So 81, for it to be to have the same base as 3, it can be written as 3 raised to the power 4. So that becomes 3 raised to the power negative x is equal to 3 raised to the power 4. So then when we reach at this point, the bases are the same. You can equate the powers equal to each other. So negative x will be equal to 4. Therefore x is equal to negative 4. So the exact value of log base 1 over 3 of 81 is basically 84. And for sure, if I look at this, if I'm to convert this back to exponential, this is going to be true. So 1 over 3 raised to the power negative 4 is equal to 84, which is true. Okay, so that's the basic idea behind this question. Okay, now pause the video, use the same concept, solve the next one. So this one, I have a provision where I can make the base to be the same. Okay, so I can either use this of equating equal to x and find the value of x, or just doing direct if at all there's a provision for me to make the base to be the same as that. So log base 2, we know that if this is 1 over something, then it can be written as 64 raised to the power negative 1. So 64 is the same as 2 raised to the power 6, now negative 6. So the property of log allows us to shift the power to become in front. That becomes negative 6 log base 2 of 2. Log of base itself is 1. So this gives me 1. So that becomes this times 1. So the answer becomes negative 6. In a case where you're having challenges on how to answer this using this concept, then you can use the same method that we used for this other question, where you can just equate that equal to, you say log base 2 of 1 over 64 is equal to x. Now you are solving for x. Convert this from log to exponential. 2 raised to the power x is equal to 1 over 64. Okay? So 2 raised to the power x is equal to 64 can be written as 2 to the power 6, but I want now the base and this guy to be the same. That becomes 2 to the power x is equal to 2 to the power negative 6. The bases are the same, x is equal to negative 6. That's the same thing. So the exact value of this is basically negative 6. As simple as that. So that is it for these two questions. So let us look at how to solve exponential equation. So we have got different types of exponential equations, but in this case we have got this interesting one. So 2 open brackets 4 to the power x minus 17 open brackets 2x close the brackets plus 8 is equal to 0. Solving this type of exponential is very simple and straightforward. So what we actually do is we have to change this to have the same as 2 to be the base. So 4 can be written as 2 to the power 2x, then minus 17 2 to the power x plus 8 is equal to 0. When I reach at this point, I can clearly see that I have got 2 to the power 2x and 2 to the power x. This tells me that this is a quadratic equation. So now we have to let 2 to the power x equal to something. So I will say equal to y. So wherever there is 2 to the power x, put y. So that becomes 2y. Now because there is 2 on top, that will be squared. Minus 17, this becomes y because it's just 2 to the power x, plus 8 is equal to 0. So this is a quadratic equation like I said. The product is positive 16. The sum is negative 17. Therefore, the factors that we're going to have is negative 16 and negative 1. This becomes 2y squared minus 6, or negative 16, sorry, minus 16y minus y plus 8 is equal to 0. Factor out 2y, I remain with y. I remain with y minus 8. Factor out negative 1, y minus 8 is equal to 0. So 2y minus 1, then here y minus 8 being equal to 0. So now 2y minus 1 is equal to 0. Y minus 8 is equal to 0. So if I shift 1 to the other side, y becomes 1 over 2. This one, y becomes 8. When you reach at this point, these are not the answers. Remember, we had to let 2x, 2 to the power x equal to something. So now our goal is to find the value of x. So we say 2 to the power x. The first answer that I found is 1 over 2. But 1 over 2 is the same as 2 to the power negative 1. So making the base to be the same, if there is a provision of making the base to be the same, then that is okay. So this can be 2 to the power negative 1. Now the base are the same, equate the power equal to each other. X is equal to negative 1. So that is the first answer that I have for x. Another one, 2 to the power x should be equal to 8. Y is equal to 8. So is there a provision of us making the base to be the same? If at all, yes. If at all we have got a provision of making the base to be the same, then we can now do that. So this is the same as 2 to the power 3. The bases are the same, equate the powers equal to each other. X is equal to 3. So these are the answers for this equation. If there is if at all you can't make the base to be the same, you introduce lean both sides. Like in this case, let us assume that we have got a situation where we have got 2 to the power x maybe is equal to 6. You can't make the base to be the same, then you introduce lean both sides. Then the property of log allows you to shift the power to become in front. So it becomes like this. In a case where you come across such questions, then you are going to divide both sides by ln 2, even here ln 2. In such case, if you can't make the base to be the same, then the answer becomes ln 6 divided by ln 2. That is the answer. Okay, so that is it for this question. So how can we solve this type of logarithmic equation. Now remember, since there is minus here, the only method that can work is simplifying this into single logarithmic. But again, simplifying this, it can't work just like this because this is in base 3, this is in base 9. So I have to change this base from base 9 to base 3. So that becomes, so now I'm changing this. So how do we change the base? If we've got log base A of B, changing this to base C, you write log using the base formula. You write B here, then here log. You write A here, then put C there. So I've changed this from base A to base C. Now using the same formula, I'm going to change this log from base 9 to base 3. So I'll write log 27 minus 2x, then I divide it by log, then I put 9. Now I want to put it in base 3, then put the base there. The bottom part can be simplified. 9 can be written as 3 to the power 2. So that becomes log base 3 of 27 2x, divide that by log base 3 of 3 to the power 2. The property of log allows me to shift the power to become in front. That becomes log base 3 of 27 minus 2x. We divide this. Now we'll bring 2 in front, then log base 3 of 3. So log A of A, log of base itself is 1. So that becomes log base 3 of 27 minus 2x divided by 2, because this is now becoming 2 times 1, because log base 3 of 3 is 1. 1 times 2 is 2. Now again, I can't leave it the way it is. Okay? If at all I have 1 over x, or let me say I have x plus 1 divided by 2, this is the same as 1 over 2, then x plus 1. So this is the same as this. 1 over 2, then log base 3 of 27 minus 2x. If that's the case, then we also know that the property of log allows us to shift the power, the guy which is in front, to become the power. So that becomes log base 3. Why am I doing this? I don't want to have anything in front because here there is nothing. Here there is nothing. I want to apply the property of log. So that becomes 27 minus 2x raised to the power half. Anything that is raised to the power half is the same as the square root. So that becomes 27 minus 2x. Now I've changed this from base 9 to base 3. Now I can go ahead and plug in. So log base 3 of x plus 4 minus, this becomes log base 3 of the square root of 27 minus 2x is equal to 0. Remember, we have got these properties. If the bases are the same, let's say base 2 of A plus log base 2 of B. If you are adding and the bases are the same, you can express this into single logarithmic, and that becomes log base 2 of A times B. Same applies to this other one. Log base 2 of A minus log base 2 of B. If the bases are the same and there is minus, then we do what? We divide. So A becomes on top because it has got positive. The guy having negative will come down. So this same principle is the one that I'm going to apply because there is minus. So this, I'm going to follow this. I'm going to follow this property. I'm going to say log base 3, because this has got positive, will be on top, then divide it by the square root of 27 minus 2x being equal to 0. As simple as that. When I reach at this point, now I can apply another property, converting this from log to exponential. So the base raised to the power what is outside is equal to everything here. So that becomes 3 raised to the power 0 is equal to x plus 4 divided by 27 minus 2x now in the square root. Any number to the power 0 becomes 1, so that is 1 is equal to x plus 4 divided by the square root of 27 minus 2x. As simple as that. So now when we reach at this point, we can cross multiply. Okay, crossing multiply, that becomes x plus 4, because here there is also 1, so if I cross multiply, x plus 1 is equal to the square root of 27 minus 2x. So to get rid of the square root, meaning I have to square both sides. So this becomes x times x is x squared, x times 4 is 4x, 4 times x is 4x, 4 times 4 is 16 is equal to, if I this square root and the 2 will go, so I will remain with 27 minus 2x. So this becomes x squared plus 8x plus 16 is equal to 27 minus 2x. This is the quadratic equation. Shift everything here to come this other side. X squared minus or plus 8x, then plus 2x plus 16 minus 27 is equal to 0. We can get rid of everything here. Okay, so what do we have? X to the power 2 plus 10x. Then if I do that is going to give me negative 11 is equal to 0. So the product that I have is negative 11. The sum is positive 10. What will be the factors? That should be negative. What will be the factors? If you look at it, that should be positive 11 and negative 1. So that this times this, that, then this times this becomes positive 10. So x plus 11 and x minus 1 is equal to 0. If you want, you can replace direct the method that you know, replacing here with what you have, this and that, but you still get the same one that I'm getting here. So this method that I'm using only work if at all I have got positive 1 as a coefficient where there's x squared. Okay, so x plus 11 is equal to 0 and x minus 1 is equal to 0. So x is equal to negative 11 and x is equal to 1. So these are the answers. Now whenever you are solving logarithmic equation, you have to test the answers. You're going to have what we call extraneous solution. So remember, we'll start with this. Where there is x, we are not supposed to have log any base with a negative here. That is undefined. So if I put negative 11 here, that becomes negative. The answer is going to be negative. It should be negative 5. Not negative 5, but negative 6, right? Not negative 6. So we have got negative 11 plus 4. What answer are we going to get? That is negative 7. So log negative 7, that is undefined. Therefore, this is not part of the solution. But if I put 1, it's going to be positive. Even here, it will be positive. Therefore, the only solution for this equation is x is equal to 1. That's all. So that is it for this type of logarithmic equation. So let us look at how we can sketch this logarithmic function. So the most important thing that we are supposed to understand is sketching logarithmic function is very easy. And one thing I want you to understand is that logarithmic function has got what we call the vertical asymptote. Okay? So now here, because there is 1 on top, to make things simple and straightforward, I'm going to change this to be ln. If there is 1 on top, that's the same as 2 minus x raised to the power -1. I can put -1 outside, because I know that if I have got 1 over x is same as x to the power -1. The property of log allows me to shift the power to come in front, so that becomes -log 2 minus x, like that. When I come at this point now, when you're sketching logarithmic functions, you equate what is inside equal to 3 things. 1, you equate equal to 0. 2, you equate equal to 1. Then you equate equal to the base. Ln is always in base e. What I want you to understand is that the one you are equating equal to 0 is what we call the vertical asymptote. So if I shift x to go to the other side, I'll see that x will be equal to 2, meaning that my vertical asymptote is that x is equal to 2. At the same time, the second one is 2 minus x is equal to 1. Then if I shift 1 to come this side and x to go to the other side, x will be equal to 1. Then for this other one, if I shift x to go to the other side, e to go to the other side, that becomes 2 minus e is equal to x. So I've got 2 coordinates for x. So when x is equal to 1 and when x is equal to 2 minus e, what will be the values of y? Let's see. So now what I'm going to do here is I'm going to start now plugging in the values. So I have got ln, negative ln 2, where there is x we put 1. That becomes negative ln of 1. Ln 1 or log 1 regardless of any base is 0. Okay? So it will be 0 times negative, it becomes 0. Now we go again, it will be negative ln 2 minus, where there is x we put 2 minus e. So that becomes negative ln 2. If I open the bracket to become negative, then here positive e. So that becomes this 2 and 2 will go, and that is e. Ln e is negative, or is 1, because ln is always in base e. So you see, ln base e of e is 1, so that becomes negative 1. So these are the coordinates that I have. After finding these coordinates, I can come back now and sketch this. So I have got my vertical asymptote at x is equal to 2, which is here. I need to draw a line cutting this point. Okay? When I do this, now in x I have got 1, so I'm going to put 1 here. E is approximately 2.718. So if I say 2 minus e, I want it to be 2 minus e, that becomes negative 0.718 something. So that number becomes approximate here. So here I'll put 2 minus e. When I do this, in y I have got negative 1 and 0. Now we can go ahead and look at our graph. 1, 0 is here. Then 2 minus e, negative 1 is there. What does it tell us? Starting from the asymptote closer, touching these 2 points, going this side. That is my graph. So that's the basic idea behind this graph. Now, How can you find the domain of this graph? To find the domain of log, we look at the asymptote. So the domain, it will start from the asymptote. So we can clearly see that it keeps on going all the way to negative infinity. So that becomes negative infinity all the way to the vertical asymptote, but not included. If you don't understand this method, get what is inside, equate it greater than 0, and solve for x. Okay? So if we solve for x, provided that on top here we don't have anything, this is going to give us 2 minus x, then greater than 0. If we solve for x, shift 2 to go to the other side, it will be negative x greater than negative 2. If I divide both sides by negative, the sign changes. So this tells me that x should be less than 2. So starting from negative infinity, less than 2, these are not included. So that becomes my domain. So that's how we find the domain of the logarithmic functions. Now, what of the range? The range of logs doesn't change. So for any log, you can clearly see we don't know where it has started from, we don't know where it's going to end. For any log, the range is from negative infinity to positive infinity. That's the basic idea. So that is it about this question.